The current technological development and those improvement in conventional and advanced biojet fuels, the aviation sector uses those specific fuels to power the aircraft. The modern technologies and now the recent technological development has been seen in conventional and some modern advanced biojet fuels. The specific fuel that power the aircraft, and these are usually classified as a jet fuel in most regions. All jet fuel has to meet those strict specifications, and it's providing the most common standard worldwide, globally, including for the renewable and sustainable fuel sources. It is the future. We can use those aviation industry and make some changes in the aviation industry fuel consumption policies as we are shifted to transform to the fuel industry as a renewable and sustainable fuel. And it has been demonstrated during several meetings and conferences by the expert body in particular sector that those are involved for the research and development for the growth and the energy transformation in the aviation sector. All are involved with this type of modern fuel consumption policies, some modern fuel consumption rules that the aviation sector will like to follow in the future days, coming days. And these biojet conversion technologies that create those pathways that can take years and include those rigorous fuel testing and evaluation process. And many of them are in using that advanced technologies. If we want to mention some of these advanced technology in the biofuel industry, biofuel mechanism in the aviation industry, the FT method that uses those high temperature treatment of any type of biomass such as wood waste, agricultural residue or some solid waste. It is also known as MSV. Municipal solid waste to produce those synthesis gases, which is then used to generate those synthetic hydrocarbon fuel over the catalyst. The thermal conventional biojet in this briefing, we can say that this aviation biofuel that derived from the hydroprocessing of oil and gas to make those fuel ready for the aviation sector, and this pathway account for the vast majority of those existing biojet. Some other important advanced biojet pathway is like SIP biojet. It is also an important type of biodiesel and biofuel consumption process that they produce biologically through the fermentation of sugars by the microorganism to create a hydrocarbon molecule called farnesene, and this is treated with the hydrogen to make this another molecule called farnesene, and this can be blended with those petroleum derived jet to produce a biojet fuel blend, and it involves the fermentation of sugar to the alcohol such as ethanol or butanol. These are subsequently upgraded to biojet and demonstrated by some important companies how it will work, how it can change the biofuel consumption policies for the aviation industry, how this industry can use those chemical mechanism, those chemical transformation for the fuel industry that can be a new game changer for this industry. And this pathway was the first to be certified as an FT pathway, and this commercial volume of those biojets from a biomass that are small because of several challenges. It include the cleanup, the catalyst contaminations, and economies of scale. Although several technical and economic analyses have assessed the biomass to the biojet pathway, many assumptions were required because of limited data and the experience. Most of these assessments have shown that it would be difficult to compete on the cost basis with fossil fuels. Despite several of these analyses, those estimating the cost of operating multiple and more established plants, therefore benefiting from economies of scale. The greatest potential of this biojet fuel lies in its ability to significantly reduce the greenhouse gas emissions in the aviation sector and positively impact the climate change. It is one of the most important considerations for their development. That's the important parameter we have to consider. We have to look for that. What is the ultimate purpose to transform this fuel industry to aviation market that can change because of this positive impact on the climate change issues. The strong and ongoing commitment to the aviation sector and the active involvement of an increasing number of stakeholders such as airlines and many aviation organizations to develop a biojet through voluntary initiative has been a major driving force behind the biojet development, consumption, and the future prospect of these new forms of fuel industries. And the number of commercial flights using biojet has increased significantly over the last few years. And the downstream supply chain has developed in some places also. The biojet offer those some heightened fuel supply system, and these initiatives for the recent development and that helps in many countries to have further help those demonstration of proof of concept and can serve as a model for expansion. Positive trend towards the overcoming those remaining technical obstacles include the ongoing research and development, and it proposed the construction of several new facilities. The cost of biojet is one of the most daunting barriers, and although ongoing is low oil prices is likely to delay the development of some biojet technologies and the project, the lower oil prices might be less for an issue for the aviation biofuel than for other sectors, because it is the industry's best interest to find a long-term solution that can be created those positive impact on the climate change, that can be a positive role in this industry, and that the municipal solid waste also a very important source of biomass material that can be utilized for bioenergy production with minimal additional input. These resources include a mixed commercial and residential garbage and paper board, plastic, leather, rubber, textile, and food waste. These are some important biofuel production feedstock as considered for a future fuel energy industry globally. We hope for the better result. We hope for the better industry adaptation. That's also important part to change in this particular sector that can drive the future in a positive environmental impact. That's all for now. Thanks for your time. See you in the next video.